Okay, today we're going to talk about contactors and magnetic motor starters. So motor starters and contactors are the interface between high and low power loads. When using a motor starter or contactor, it is possible to use a switch that is rated at a few volts and milliamps to control a load that is rated for hundreds of horsepower or amps. So this is a knife switch. This is what used to be used in the industry. So when motors were first introduced, they came up with a method called a knife switch to start and stop them. They were eventually discontinued for 3 reasons. First reason being, the open knife switch had exposed electrical parts, so that is a hazard, obviously. 2, the speed of the open-close mechanism was based on the operator. So why would that be bad if it's based on how fast you can open or close it? That's going to be because that can cause arc flashes, and would eventually wear out the switch because there's no way that you can do that fast enough. Most of them were made of soft copper, which required replacement after repeated arcing, heat generation, and mechanical fatigue. Their use today is disconnects. A disconnect is a device used only periodically to remove electrical circuits from their supply source. So manual contactors. That's a control device that uses push buttons to energize or de-energize the load. Cannot be used to start or stop motors because they have no overload protection. So a manual contactor cannot start or stop a load or a motor. Usually in the same enclosure as a fuse or circuit breaker. Double break contacts. Breaks an electric current in 2 places. Allows higher current ratings in smaller spaces than single break contacts. They're used in push buttons. A mechanical interlock is the arrangement of contacts in such a way that both sets of contacts cannot be closed at the same time. Lack of interlocking can cause shorted circuits, injury, damages to motors, machines, etc. Manual starters. A contactor with an added overload protective device used only in electrical motor circuits. Manual starters have overload protection. Manual contactors do not have overload protection. Required by the NEC that a control device will not only turn on a motor or turn a motor on or off, but also protect it from overloaded situations. That's why it has overload protection. Motor overload protection. Under normal operation, motors go through 3 stages, and that's going to be resting, starting, and operating under load. When motors first start, they draw in massive amounts of current. Fuses and circuit breakers need to have a high current rating to prevent immediately tripping the circuit when the motor first starts. The fuses or circuit breakers must protect the motor circuit from short circuits and ground faults. To do this, overload relays are designed with a time delay. This allows the harmless temporary overloads when the motor first starts, without tripping the circuit. So it's estimated that every 1.8 degrees Fahrenheit that a motor rises above its insulations rating, that can reduce the life expectancy of a motor by up to a year. So that is why it's really important to have overload protection, because if a motor overheats, it's going to destroy its insulation, and that's going to decrease the motor life by up to a year, even if it just raises 1 degree above that rating. So these are some examples of an overload relay, a manual starter, and a manual contactor. I know you can't really see that great, but these is just what you would see with us working in the lab and everything and out in the field. So an overload relay is on our left, manual starter, and a manual contactor. Magnetic contactors. Contactors are either opened manually or magnetically. Solenoid action is the main operating mechanism for magnetic contactors. Linear action of a solenoid is used to open and close sets of contacts instead of pushing and pulling levers and valves. Remote control and automation can be designed into a system using magnetic contactors. Little side note, contactors have either an AC or DC coil, but could have either AC or DC contacts. So they have either AC coil or DC, not both, but could have both AC or DC contacts. Arc suppression. An arc suppressor is a device that dissipates the energy present across opening contacts. All contactors and motor starters require arc suppression. Magnetic motor starters. Electrically operated contactor that includes motor overload protection. They are available in sizes that can switch loads of a few amperes to several hundred amps. Mechanical and electrical interlocking. So this is what it would look like if you put two contactors together to form a mechanical and electrical interlock. And we're going to do that in the lab for one of our labs in the future. So what is a mechanical interlock used for? It's used to physically prevent both contactor armatures from being closed in at the same time. It disables one circuit breaker. So mechanical interlock is used as a last resort. Electrical interlocking is what you should rely on. So whenever that's energized, it should create an electrical interlock, depending on how you wire it up. And that's gonna prevent you from pushing both buttons at the same time. So that means you cannot run that motor in forward or reverse at the same time, because that's going to burn up the motor if you try to do that. So this is wired up in a way that the electrical interlock should prevent you from doing that. But if it ever did fail, then that mechanical interlock is going to prevent it, and it's going to make an awful noise, and you're going to know that something is wrong with that mechanical and electrical interlock. So this is just kind of drawing it out, what it should look like. You can see that your stop is your push button 1. And then moving on, you have your forward, where F1 would close, and your forward would come energized. And then you have it designed to where if your R1 closes, your reverse would become energized and your F1 would open. So you have to wire those up to where if one closes in, the other opens. And you cannot close in the other. And then you have your overload protection before you go to your motor. So just to reiterate what we went over mechanical and electrical interlock, magnetic motor starters, arc suppression, magnetic contactors. There's those pictures again in case you want one more final look. Motor overload protection, very important. Manual starters, double brake contacts, manual contactors, and there's a knife switch.